college, we are required to balance our social life, academic life, and sleep all at the same time. And while this is a hard feat to master, what some college students fail to realize is that we physically balance every day. For example, when we get up out of our seat, when we wake up from our bed, or walk to class, we use balance every day. And besides using it every day, it's because that's an important part, it also keeps us safe. And that's a crucial part, is because we don't want to fall. And after reading numerous amount of articles and research papers on balance, I now understand how elaborate the process can be. And I will share these findings with you, and by the end of the speech, I hope you understand how we balance and what factors affect balance. Balancing with our eyes open is different than balancing with our eyes closed, and that's because we can look at visual reference points. These visual reference points are images sent from the retina to the cerebellum via the optic nerve. And this signal tells our brain our head's relative position with respect to the ground, and therefore our body can make adjustments. And the cerebellum is important because it's the part of the brain that controls our movement, coordination, and balance. And the cerebellum is also an important part of the vestibular function. The vestibular function is the system in the body that controls our balance. And besides the cerebellum, the muscles and joints in our body, signals sent from our eyes to our ears and the inner ear are a part of the vestibular function. So like I said, balancing with our eyes closed is different than balancing with our eyes open. And that's because we have to rely on the inner ear. There are three parts of the inner ear: the cochlea, the vestibule, and the semicircular canals. And the inner ear is composed of tiny little bones known as the bony labyrinth. And the bony labyrinth has a membranous labyrinth inside of it filled with endolymph, a type of fluid. And now the cochlea is only part of the hearing, but the vestibule and the semicircular canals are part of balance. And the semicircular canals, we have three of them, each positioned at 90 degrees to each other. Imagine X, Y, and Z axis. And that's important because we need to send accurate representations of our body's relative position to the ground with respect to the brain. And that's because if we're standing up, our head is perpendicular to the ground, versus when we're sleeping, it's parallel. And those are two different head positions, but we're balanced. And that's because, depending on our body's position, a particular vestibular or semicircular canal is in charge, and that semicircular canal will send the signal via the vestibular nerve to the cerebellum. And the semicircular canals are only in charge of our angular acceleration, so the spinning and twirling of our body, for example, this dancer. And at the base of the semicircular canal, where it's attached to the vestibule, we have the ampulla. And the ampulla is a bulge. And at the base of the ampulla are hairs, and hairs are in inner ears. And they have the vestibular nerve connected to them. Now the hairs are encased in a subpulla, and this is a gel-like membrane. And so when the endolymph comes through, when our body position changes, for example in this picture, it pushes the subpulla, which then pushes the inner ear, or the hairs in our inner ear. And when the hairs move, it sends a signal via the vestibular nerve to the cerebellum, or particularly the pons, which is part of the brainstem, to the cerebellum. And this is how our brain knows our position. On the other hand, the vestibule, the other part of this, the inner ear, is in charge of the linear acceleration. And the vestibule has two specialized organs in it, known as the utricle and the saccule. And the utricle is part of the horizontal component, as you can see, and the saccule is part of the vertical component. And what's different compared to the semicircular canals is that there's no ampulla, there's no bulge in it. Instead, we have ortholiths, which is a calcium particle connected to the hairs through an ortholithic membrane, so we still have a gel-like substance. But unlike the other one, the endolymph, the blue picture in this drawing, pushes the ortholiths down depending on the direction of our head. So it would be, the yes motion or the no motion. And this will cause the ortholithic membrane to move, pushing the hairs in a certain direction, which then sends a signal via the vestibular nerve to the cerebellum again. And so this is how our brain, or our body, tells our brain our head's position, and then it can make necessary adjustments as needed. Now there are three things that affect balance. We have fatigue, dehydration, and age. And fatigue is an important one because as our muscles are strained, they get tired, they become weak. And as they become more weak, they cannot support our body strength, and this will cause us to be more prone to falling. Likewise, if we stress our body a lot, we will become dehydrated and lose water. And this will affect our balance because the endolymph, the fluid inside the membranous labyrinth, will become more dense and sugary. And this will not allow the hairs to move as freely. And therefore, this will send inaccurate signals to the brain, which we do not want. But also age. Age is one of the biggest factors because it has 3 components within it, and that's just muscle strength, hormone production, and the vestibular function. So as we age, we usually decrease the amount of physical exercise we do just because our muscles get weak, and this is what we do not want to do. Because we want to keep on exercising, keep on working those muscles, including the cerebellum, so that they can become stronger as we age instead of decrease. Likewise, as you can see from this graph, the growth hormone and, for example, the testosterone, decreases as we age. And if we do not have hormones produced in our body, we cannot build the muscles in our body, and this will again decrease muscle strength. And the final one is the vestibular function. And this graph is by Timothy Hayne in 2010. And so, as you can see, by the time we're 80, 50% of our vestibular function will be gone. And if 50% is gone, and the vestibular function controls our balance, this is pretty much saying that 50% of our balancing skills will be gone by the time we're 80. Finally, I encourage you to share these results, not only to your loved ones, your friends, your family, but also to older individuals, because you're encouraging them to stay active. Because if they stay active, they can increase their muscle strength and keep them from falling and having fatal injuries in the future. This is also telling the young ones to stay active because we need to keep the muscles engaged so we do not lose the strength as much. So when we're older, we have the strength to prevent those fatal injuries in the future. Thank you.